Hello, this is a tutorial to introduce you to Project 1 in the course ELT130. And so if you go on the class Blackboard page and click on course content under week 1, if you open that up and scroll down a little bit, you'll see Project 1. So the project handout is right here. You just click that and it's a Word document. So just open that up. All of the project handouts in this course have a section called Deliverables, which are the things you're going to be responsible for. Now in this project, you have 2 programs you're going to write and submit on Blackboard. The third part here, if you were in the lab, you would demonstrate the programs to the instructor, but since you're working at home, you're not going to be able to do that. In this lab, we're going to connect some simple components to the Arduino output. In the first part of the lab, we're just going to need the LED. So I'm just going to connect this resistor and LED to the Arduino output. And then in the second part, I'll add the potentiometer. So notice that the LED connects to this ground symbol. That symbolizes a connection point on the breadboard. That same connection point has to also be connected to the Arduino's ground pin. It's actually Arduino has 3 different ground pins. They're all connected to the same place. So it really doesn't matter which one you connect to. So that's the first connection I'm going to make. I'm going to go from the Arduino ground pin, and I'm going to use this breadboard bus line. So if you remember, if you've taken ELT103 and ELT121, you've done some breadboarding, but just to remind you, what you're seeing here is a breadboard with the adhesive backing peeled off. Now don't do this with your own breadboard because you'll ruin it, but I have this as an illustration to show how the connections work. Those connections on the sides of the board are long metal connection points that run the whole length of the board. And then the connections in the middle are these short little connections that can connect up to 5 different components, 5 different leads can connect in there. So those you typically would use for power connections and ground connections because lots of things on your circuit are going to connect to those. So that's why I'm using that for my power bus. Now the LED is going to connect from ground to one of the connection points on the breadboard. Now we have to make sure we connect the LED in the right direction. So if you look at the LED, if you haven't clipped the leads yet, the shorter lead is the cathode, which is the one right here, the one that is going to connect to ground. If you have cut the leads, then you can also tell where the cathode is by looking for the flat mark. There's a flat spot on one side of the LED body. That marks the cathode. So I'm going to plug that into ground, and I'm going to plug the other one into a connection point. Then I'm going to take the 330 ohm resistor and connect it to the same connection point as the LED and out to another connection point. And then that point on the schematic is here, is going to connect to pin 13 of the Arduino. So pin 13, here's the connection point to the resistor, and pin 13 is out here. That's one of the digital outputs. So now let's look at the software. You're going to start with the Blink program. I'm just going to copy this into the Arduino programming window. And the first thing to do is to just upload it to the Arduino. Make sure you have the right COM port selected and go upload. And you should see the LED blinking on and off, 1 second on, 1 second off. You'll also notice that the built-in LED on the Arduino is also blinking because that's connected to pin 13. Now if the LED is not blinking, things to check are make sure it's plugged in the right way. If you plug it in backwards, it doesn't allow current to flow. Make sure the connection points are in the same row, or then, so that they're actually connected. A very common mistake is to offset by one. All these little details will have some effect. Make sure your ground connection is there. If any one of those connections is not there, you're not going to get the LED to light up. Okay, so we've got an LED blinking on and off. Now, what I'm going to do, as an example, in the lab, you're going to modify this program to create the SOS Morse code signal. And at the last page of the lab, I give you a table which describes Morse code. I'm going to do an example where I'm going to spell the word IT, I-T, 2 letters. To spell the word IT in Morse code, if you look at the Morse code diagram, I is dot dot and T is dash. Now there's a description up at the top that explains how to arrange the dots and dashes in the correct timing. First of all, it's all based on this thing called a time unit. And we're going to use 200 milliseconds for the time unit for the lab initially. So a dot is 1 time unit in length, and a dash is 3 time units. And when you have dots and dashes together, the space between them is 1 time unit. When you've completed a letter and you want to do another letter, you have to make 3 time units between each letter. And then when you've finished a word, it's 7 time units. So let's translate that into a timing diagram. So it is dot dot dash. So what we're doing essentially is turning the LED on or off. So initially we're going to turn the LED on, and we're going to wait for 1 time unit, which is 200 milliseconds in our case. Then we're going to turn the LED off, and then we're going to wait 1 time unit before the next dot, because there's supposed to be 1 time unit between dots. So we're going to turn the LED back on again, wait 1 time unit, that's the second dot, and then off. So there's the letter I, dot dot. Now, the space between the I and the beginning of the T is 3 time units. 1, 2, 3. Now we're ready for the dash, so we turn the LED on. And then the length of a dash is 3 time units, so 1, 2, 3, and then off. Now we're going to repeat this pattern, but the space between each spelling of it has to be 7 time units. So 1, 2, 3, 4, 5, 6, 7. And then that would start the pattern again. So this would be right back to where we were, so we don't have to do that again. All right, so let's, if we just put this in terms of, this is called pseudocode, we're just kind of writing what we're doing. We're turning the LED on, we're waiting 200 milliseconds, we're turning it off, we're waiting, I'll just abbreviate WT 200. We're turning it on again, right here. We're waiting 200. We're turning it off, waiting 600. That's 3 time units. Turn it on, wait another 600. That's the dash. And then we turn it off. And wait for 7 time units. 7 times 200 is 1400. All right, so let's translate that into commands. So back on the Arduino programming window, we can use these commands. We've already got the digital write high and the digital write low. Just need to change the delay to 200 to make that a dot. And then it goes off, and we're going to change that to 200. And I'm going to change the comment also because so it matches what we're actually doing. Actually, why don't I do this? I'm going to say 1 time unit. So in case we change the time unit, which we will later on, we don't have to retype that. So there's 1 dot, and I'll just copy that whole thing, paste to make the other dot. So high, low, high. Now, after that second dot, we have to create 3 time units of space. That's 600 milliseconds before we turn on the LED again for the dash. And so I also need to change the comment. So wait for 3 time units. And we turn the LED on. We wait for 3 time units. That's 600 milliseconds because we're creating a dash. And then we turn the LED off after the dash to complete the dash. And this is the point at which it's going to go back and repeat because we've just done dot dot dash, but we have to wait 7 time units before we repeat the word. So that would be 1400. All right, let's upload it and see how it goes. Okay, so the LED is now doing the Morse code for it, dot dot dash, and then waiting 7 dot dot dash.